So in previous videos, we've looked at linear regression, which is a very good introduction into machine learning models and how we use gradient descent to find the parameters. In most cases, however, in real-world problems, that your response y may not be a perfect linear combination of your input x. So what happens is that you need to introduce some nonlinearity into your model. Now, there are many models out there you can use to model nonlinearity, including using neural network, which we are going to talk about in the next lecture. But I just want to point out that there's a big family out there you can do nonlinear regression, and that is called general additive models. And the idea is that, say, if you have a linear equation here, y is just a linear combination of order x, and sometimes this is written like in some textbooks, you might find something like this: a1 ai times xi, where x0 is equal to 1, so that this term can be 4 less a0 times x0. And you can also write this in a matrix multiplication form as well. But they all mean the same thing. It just means your input do some linear combination will become the output. So if you look at each term here and then just try to think about this as a function of each of these features, like x1, x2, what happens is that we can think about a more general term. So we can try to think, okay, this term is just f1, which applies on x1. And in this special case where it's a linear function, then the f1 is a linear function of x1. So what happens is that we can replace f1 with other nonlinear functions, and we call these different f's basis functions. So if the basis function is a linear function, then you are doing linear regression. If the basis function is a nonlinear function, then what you are doing is a nonlinear regression. And then the next question is, what basis function are out there for you to choose from? And it turns out there's a big category, a big family of functions that you can choose. I just list some here. For example, you can expand it to polynomial. For example, each of these x will become, for example, x1, x2 square, x3 square, etc. And there's another linear combination there. But the whole thing is a nonlinear function with regard to x. And apparently there's a hyperparameter, which means to what degree you need to expand this to. You can expand to the third polynomial or the fifth or the 10th. But just recall the previous example, if you have more degree of freedom here, the model might fit the training data quite well, but fail to generalize to other data. So be careful about this. So again, this is a parameter you need to define before you actually do the expansion. So this is called a hyperparameter. So similar to polynomials, you can also use splines. And again, there are many splines out there. One of them is called natural splines. And you can probably tell from the name, it will look quite smooth. If you are interested, just Google how you can do natural splines in Python. And there are many tutorials out there. Similarly, there's a degree of freedom, which is a hyperparameter you can set, just similar to the order of polynomial here. But in this case, it's just called degree of freedom for the natural splines that you can expand each of these basis function into.